Guys, welcome back, and let's continue with the next part. In the last class, guys, if you remember, we was talking about cryptography, right? So, technically, uh, this class is not about purely about security, right? We are into the AWS training, but without knowing some of the basic concept of cryptography working in the service that is very much related to the encryption would be very harder. So I try as a simple level, try to explain you what is cryptography and some of the terminology related to cryptography, right? so so in the last class, guys, we had seen a practical of symmetry key. Okay, and I showed you how to integrate symmetry key with EBS, or how to put your private key or your symmetry key in your KMS service. Plus, how to use your symmetry key also in Lambda, right? So, multiple different examples I explain you in my last class. So today, the today's my focus area is two different topics, again related to key and security only. So there's one service in AWS, very new service. It's called ACM. Okay, it is Amazon Certificate Manager. Okay, so you can think it is something like a CA. So anybody who know cryptography, um, we have certificate authority who sign a certificate to us, something like this. This will provide to you and much more than CA. Okay, so ACM is a one service that we are going to discuss today. And again, in key management service, right, we had talked about secure symmetric key. Today I am going to explain you what is asymmetric key and how we use. Okay, and to showing this demo, I am going to use elastic load balancer. Okay, and to convert our communication with HTTPS. So till date, guys, if you see what are the load balancer and service we use, normally we use HTTPS. But today, after we having this topic to complete, the demonstration would be on ELB load balancer, that through which we communicate with this ELB with HTTPS. So this is the guys high level agenda for today's class, right? So let me start the things one by one. Okay, so very quickly I want to first summarize what we have done. So intention is simple. You have a data that is normally known as plain text. Okay, and you think wherever data you are storing, normally guys, you store your data in the hard disk or storage, that is called data at rest. Okay, or maybe you want to transfer the data via network. Okay, so you have a network, so from one computer to other computer you want to transfer the data. Okay, and that is also known as data in transit. Okay, so if your data goes or your plain text goes via network, that's called data in transit. Or if your data is storing in your hard disk, obviously in some of the file, that's called data at rest. So if you think this data is very critical for you and you need to provide a security, means somehow anybody get the access of my hard disk. This hard disk, maybe let's say your pen drive, or maybe your pen drive miss, or somebody stolen your pen drive. uh, Obviously anybody can plug the pen drive in their laptop, and by plug, pen drive come up and they can see the data. Okay, so point is, guys, if my storage, my pen drive, my hard disk, extra hard disk have been stolen or by missed by somehow, I don't want, right, and that anybody can see my data. They can delete, they can format or reformat, anything they can do. We can't stop on that part. But I don't want they can see my data. Maybe this might be my password, something like this. So if this is the case, so what you have to do, whatever data you store in your hard disk or in a storage, okay, you have to convert this data in some other format, some in some binary format, and that is called ciphertext. Okay, ciphertext is text that nobody can able to. They can read, but they can able to understand what exactly written over there. Okay, so if you want to convert plain text to ciphertext, this process is called encryption. So, guys, this part we have discussed yesterday, means in my last class. Okay, but if you want to encrypt, if you want to encrypt, obviously you want nobody can able to again decrypt this data and again get the plain text. Okay, again get the plain text. That's called decryption. Okay, so you want to have this control with you only. So for encryption, what you normally do, you create a key. Okay, and this key will always with you somewhere. Okay, and this key, because we're using same key for encryption and same key for unlock, that's called decryption. So this key is known as symmetric. Okay, and there's a lot of algorithm available in the market. I'm not asking the tool. Okay, there's a lot of tool or command available. One of the very famous command in Linux or Unix system is called OpenSSL. It is also available for Windows also. So these are the tools or the command available. Okay, to create some key for you. But if you want to create a key for symmetric key, so for this we have a lot of algorithm available in the market. But one of the very famous and powerful algorithms is called AES 256. Okay, so this is one of the very most powerful, or I can say one of the powerful algorithm, right? That is very harder. Till date, it is very impossible to break this algorithm. Okay, so we can use this algorithm to create a key that is called symmetric key or shared key maybe, and we use this key to encrypt the data. Okay, now it is your choice. It is your choice. After you encrypt your data, you want to keep this data after encrypt. That's called ciphertext, or sometimes also known as cipher blob. Why blob? Because data finally would be in a binary format. So blob means binary object. Okay, so after your cipher text created, or your data log, or it become convert other format. Okay, so this data you want to store in the hard disk, means data at rest, or you want to transfer somewhere to other computer, means data in transit. So that would be your choice what you want to do with the data. But in both the cases, I want security in both the cases. So before you transfer or store your data, just convert your data into the ciphertext. So that's what, guys, we had discussed in my last class. But the main thing here is, right, anybody by somehow get access of your key. Guys, again, understand here, I'm not using the word private key. Okay, private key and public key we use in asymmetric world. That is a today's topic. But anybody who by chance get your symmetric key, okay, or the key created from this particular algorithm, or you have more algorithm, okay, they can very easily, one click, they can unlock your data, or that's called decrypt your data. Okay, so the most important thing is where we are managing our key or keeping our key. So you keep your key on a pen drive, Gmail ID, wherever you want to keep, you can do it. But for the company perspective, industry perspective, there's hundreds and thousands key for different teams, different requirement. So they need some kind of management system, and here they can use KMS. So a key management system is a service from AWS. Okay, where you can keep your key, and it's managed service, means wherever they are managing, they're giving a guarantee of availability, they're giving a guarantee of high availability, they are giving the guarantee of security, everything they are giving. And where they're keeping, that would be their choice. Okay, but they're giving that your key would be safe there, and they are almost giving 100% guarantee. So KMS is a one service where we can keep the key. And interesting thing is, now we don't have to create the key also. We can ask the KMS, they will create a key for me. Because if you create with OpenSSL, right, or if you ask KMS to create a key in any of the cases, behind the scene, they're going to use same kind of functions, all the algorithm. So it doesn't matter who going to create the key. So we can ask the KMS, they are the one who will create a key, and sometimes it's also known as they will provision the key for you. So they're creating the key for you, they are managing the key for you, and other things also they are doing. So that is the only use of KMS. Okay, but This part we have done and we have discussed. So before I go for guys asymmetric key, I want to show you one more quick demo of symmetric key. Okay. So in my last class, guys, I show you how to encrypt your environmental variable of lambda with symmetric key. Plus, I also show you how to encrypt your EBS volume, because I want whatever data I store in my storage, it will be encrypted again with your symmetric key. So in any of the area where you think you are the one who want to keep your data locked or encrypted, and you are the one finally who are going to unlock, in this kind of use cases, symmetric key is useful. Okay, but what is the use case of asymmetric key? We will discuss in a minute, right? But before this, I want to show you one more demo. Okay, this demo is related to S3. So what is S3? You guys know. So technically, S3 is one object storage where you keep your data in a cloud. It's called cloud storage also sometime. Okay, in the cloud, and okay, and your data is stored in a file, and file is known as object. So you know guys about S3. We have done a lot of demo of S3, right? But technically whatever data you store in S3 object storage as a service in the cloud, obviously finally for example, you are a user, you have a file, and whenever guys you upload a file, this file will be uploaded to S3. And what is S3? They have their own data center in AWS. In data center, they have a lot of hard disk and storage, and some of the hard disk, S3 is one service or one program. They take this file and they store this file in some of the hard disk on the cloud. Okay, but who is managing this hard disk? Okay, obviously they have their technical persons over there, a human being over there. They are the one who is managing this hard disk, adding the hard disk, removing the hard disk. And even though they have a way, this is those normal hard disks, they can keep their laptop, and after they keep the laptop, they attach this hard disk, and whatever data they have, they can access, or they can read also. Obviously they're not doing this is a big company, they give you proper they have proper, we have proper reliability. These are the reliable company, I can say. They are not doing, but there is chances they can do it. Okay, so if your data, whatever file you're uploading, if you think it is so much secure, so what you do after you upload the file, okay, and before this file is stored in this hard disk, we can purely encrypt this file. Or when I encrypt the file, which means my data is also encrypted. Or I can say I can encrypt my object, because in S3 file is known as object. Okay, so that's what I want to do. But understand one thing, in this case, I am a user. Let's say my name is Vimal. Okay, and this is my file. This is my store because I purchased from the AWS. Okay, so I'm keeping my file, okay, in encrypted format, and for this I need a key. Okay, but because I'm just an individual user, so I just one key is enough for me. What I mean by this, when I explain you asymmetric, you can compare there. Okay, so I can use my key to encrypt, and same key I can use for decrypt, because I'm not going to share the key with other person, right? So one key is enough for me to lock or unlock. So in this case also, I can go for symmetric key, and you can use one of the algorithm, maybe AES algorithm you can use. Okay, so let me guys show you how to encrypt your data or object in S3. By default, they won't encrypt. So if you go to S3, and what data we have uploaded till date, none of the data has been encrypted. Okay, so so this is let's say this is one of my storage. Okay, and in this storage we have uploaded one file. Okay, and if we see the detail of this file, okay, somewhere you will see somewhere they have posted here, okay, that your server side encryption is none, means your object is not encrypted, right? So by default, they whatever data or file you upload, okay, they won't encrypt your file. Okay, but if you think this data is very critical for you, you can go and encrypt this file. How? For this, there's three different method, guys, S3 support to encrypt your objects. So if you go to S3, Okay, S3. Understand one thing, guys. In S3, we are the user. This is our bucket. Bucket means folder. Inside bucket, this is our file, and this is my account. I'm logging for my account. Okay, so 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 1 minute. So technically, when you talk about encrypting your data out of the file, means data at rest. So technically, we have to technically use symmetric key only. Because this is my storage, I have to encrypt and I have to decrypt. What I'm trying to keep on pointing here, because a lot of guys confuse when to use symmetric key, when to use asymmetric key. So I haven't talked about yet asymmetric key, then I can very much relate. But again, this is the example where I can go for symmetric key. So if you want to encrypt any data in S3, or I can say object, we need symmetric key algorithm. But three different way they support. So that whatever you feel like, you can use that way. Okay, one way would be okay, one way would be again same thing I'm repeating, you need a key. Okay, now question is, who create this key for you? So one thing I can do, I think Amazon is a very reliable company and service. So I can ask Amazon, do one thing, you create your key, okay, and you manage your key at your end. So you're providing me S3, or you have your, and you have your own cloud. So for me, you are the server, okay. So you will go and manage and create this key for me. Okay, so I rely on you that you don't misuse this key. And now whatever object I upload, use your key, okay, to encrypt my object. Okay, so this is one of the way where I'm asking Amazon that you create and you manage your key. Okay, so this is called, guys, managed key. That's called managed key. So this is one of the method we have. Okay, other method would be would be, I can tell my Amazon that I don't want to use your key. Okay, I have my own key and I'm keeping my key in one of your service that's called KMS. So I keep my key there. Either I ask you to create, or either I uploaded my key there, or maybe I put my key in in your hardware security appliances HSM. So somewhere I'm keeping my key. So I don't want to use your key that you manage internally. I want just go to my KMS where I keep lots of keys. So one of the key I'm going to use, and this key I will use to encrypt the object. So this is the one of the method. Okay, and one possibility may be, okay, I am a client, I am a user, I am the one who will going to upload a file or the object. So what I do while uploading the file, okay, so in my laptop, in my OS, I will create my own key. This key is I create in my laptop, I store in my laptop. Okay, and whenever I upload any file or object over here, so while uploading, I use this key to to encrypt this file. And then after file encrypt, then only I will upload this file in your S3. So this is also one more method we have, where we as a client or as a customer will use their local key to encrypt, then we'll upload. But technically, I want my data to be encrypted. Now, whatever method you want to use, that would be your choice. Okay, but in this case, right, in method 1 and method 2, okay, who is encrypting your data? Your server is encrypted, or your AWS is encrypting your objects. So this two method is called server side encryption. So this is also server side encryption, and this is also server side encryption. Okay, but by chance, in this encryption, this method is known as server side encryption. Okay, and where we are using a managed key in S3. So this the name of this process called SSE-S3. So this is the name of this method. Okay, in this method, again, server is the one who are going to encrypt. So this is called server side encryption. And what we are using here, we are using KMS key. So the name of this method is called SSE-KMS. Okay, and this is this is known as again, By chance they are using the word server-side encryption only. Okay, but this is known as C, means a customer. So SSC hyphen EC, this is the name of this this particular process. Okay, and why they are saying SSE here also, server side encryption? There's one reason. When I'm showing this demo, I will explain you why they are saying this method SSE also. But technically, hyphen C means the customer. So there's three different method available. Okay, for encrypting your object before you store your data at rest. Okay, so that's the three method they support. Okay, so let me explain you one by one. The good thing about the first method is because this key is managed by AWS. So what they do, okay, for every object you upload, they use different key. So file 1, they use key 1. File 2, they use key 2. File 3, they use key 3. So there's a great thing, guys, they do if you're using managed key method. You don't have to manage, they will do everything for you. Okay, but for every object they use unique key. One of the reason maybe, even though they are keeping the key in very secure way, but by chance one of the key compromise, you only lose this file. Other file would be keep secure there. So this might be one of the things you can think of, right? But if you go to KMS, okay, all of your file or all of the object will be encrypted by that key, whatever you attached. Okay, so all the 10, 20, 100 files you have to encrypt with the same key, or maybe in the KMS you have multiple key, but technically if a 1,000 file, you're not going to create 1,000 different symmetric key by yourself. Okay, so normally you use 1 or 2 different keys to encrypt. Okay, so this is one thing here. Okay, so let me show you this demo how we can use this. So for this demo, obviously for second demo, you should need KMS key that I already have in my last class. But let me show you this demo one by one. Okay, so what I'm doing here in S3, let's do from where we start. Okay, I'm going to create a bucket. Let's say this is a test. Let's go bucket 2222. I'm keeping this bucket in Mumbai region. Okay, block all public access, you guys know, and that's the different one. And by default, guys, see here, when you're creating the bucket, your by default option is disable. Okay, it's disabled. Let's keep it disabled, right? I'll show you how to enable afterwards. So new bucket has been created. Okay, in this bucket I don't have any object. How to upload the object? Pretty simple, you guys know. Okay, I click here and let me upload, let's say this file. Uploading. Okay, so by default, guys, when you upload any file, okay, the default encryption is disabled. It means your file will upload and store in your what is it? Store in your storage, but at rest they will be in the plain text. Okay, that's the one thing. If you see, server-side encryption is none. Okay, but if you want, the file that I'm going to upload afterwards would be encrypted. But understand one thing, guys, right? Whatever data you have till now, it would be purely plain text. After upload the file, if data keep in your hard disk in the plain text, so they're always in the plain text. So there's no option as such. Okay, so whatever file you have, and after upload you want to change and say I want this file to be encrypt, you can't do it. Okay, so there's no SL way. We can create some kind of script. There's a different point. The key will again download this file, again delete this file, again upload this file. So after next upload, it will encrypt it. So by default, if any file you uploaded and that time you doesn't you didn't encrypt it, so afterwards there's no options to again encrypt. Okay, but we can create some kind of some kind of pipeline, some kind of program, or some kind of script. They will do something for you and they will encrypt. There's a different point, but by default Amazon doesn't provide this facility. So there's a different point. Let's come to main point here. So let me go to my my bucket here. By default nature of the bucket right now is everything is in stored in the plain text. But if you want to change, right, then there's an option called properties. Go to properties. Okay, go down, and there's option here called disable by default. So what I'm doing here, edit. Do you want to enable? I say yes. And guys, here now they're talking about which kind of um, which kind of encryption you need. And now they have three. One is managed. The first one, this one you want, or do you want this one? Second you want, or you want to upload object with the customer provided encryption. You want this one. And for this, there's no option here, obviously, because customer has to provide their key. So while uploading, they have to first encrypt the file. So there's no option here. We have to use some command line. I'll show you that one. Okay, so let me go for this one here. This key is managed by AWS for us. You don't have to do anything. Okay, now save change. Now this property, guys, I'm changing in my bucket. Means anything that you upload in this bucket will be encrypted. So again, guys, for planning purpose, you can create multi-bucket. So one bucket we can create where you want to keep all your secure data. So that make this bucket as a encrypted bucket. Okay, and whatever data you don't want to encrypt, just create a separate bucket and keep your data in that bucket. Because obviously, if you put your data in encrypted, the processing will be slow because they have to encrypt, and for encrypting they have to use some CPU cycle. So overall process will be comparatively slow. So always encrypt the data that you want to be encrypted. Okay, now this is being encrypted, and they are using SSE S3. Okay, now what I'm going to do, I'm going to upload one more object. Okay, this object, I'm going to upload this file, and let's say this file is very sensitive for me. So good thing is, guys, as soon you upload, you can see now this is encrypted, is enabled. So as soon you upload, okay, behind the scene, before Amazon store this data in their storage, they use their one of the key or one of the unique key, and then they store your file. So now this file is been encrypted. Okay, now if I go to configuration, if you see here, whatever the file you are uploading, your file is protected at rest. Okay, this is because of the bucket setting we have done. So that's all, guys. So now we see, guys, you don't have to do anything. Everything is internally done by AWS. And interesting thing is, if you want to use this file, and because I am the owner of this file, I am the owner of my account. So if I want to use this file, I click and download. Okay, but interesting thing is, right behind the scene, before I download, Amazon behind the scene will use same key, whatever the key they use, and they first decrypt this file for me, and then they provide to me the actual data. Okay, so all the encryption and decryption behind the scene done at the server end. Okay, so this is one thing. So this is one thing about this file. So this file is using encryption. You will see here also this called SSE. Okay, but if you want to use a different encryption, so what I do, I can go from bucket, change my property. Okay, and I don't want to use SE encryption. I can go here and edit and say I want this one, this encryption. Okay, whenever you open this one, it automatically asks you which key you need. Which key you need. Okay, so whatever key, guys, you have in your KMS, you can use here. If you guys remember, in my last class, we had created some of the key in the KMS. So let me very quickly open my KMS service. Okay, so in my KMS service, I have a key called my key LW. By some guys, I deleted this key. That might be reason they are not showing you. But but if you create a key here, let me create very quickly. I want to create a symmetric key. This is the main topic for today. I want to create a symmetric key, and I want this symmetric key stored in my KMS. Okay, And this one, guys, we did already in last class. Okay, let's say this is a key for S3. Okay, and I'm skipping this part. It means anybody can use, anyone, right? So root is allowed, or not anyone, actually my root account is only allowed. Okay, and that's all. So this keys be created, and this symmetric key, and Amazon managing this symmetric key for encryption and decryption. Okay, now I go to mastery. Okay, and here I can say, let me again cancel and go back to reload. So I can just go and change and say I want to use a key from KMS. Okay, and choose the key from master key, and this is the key you have created, key for SSD. Okay, you can also create from here also. Actually they keep on small changing the look and feel of the portal, right? But yeah, logically this is the way we can collect. So finally, again, your key, your object encrypted, but here object is encrypted with key, and that key is managed by KMS in our account. So this is my personal key that I can have a control, right? So the only thing is, if you use this key, you don't have a control. So guys, in cryptography, normally is a very common pattern. Every some days or month or year, we keep on rotating the key. We delete older key, we use new key. So there's a lot of things we have to control. We have to do auditing on the key. So if you use AWS managed key, there's no options to rotate the key or audit the key and some more thing. But if you use KMS, and because this is the key come from your account only, so there you can go and do some kind of auditing or controlling and something like this. So in this case also, this is the good option to use. Okay, so this one, and let me save. Okay, so now in this bucket, they are using SSSE KMS key. Now if I upload any of my new object, okay, then this object will be encrypted by, for example, this file. Okay, so this will be encryption enabled, and as we upload, this file will be encrypted with the KMS key. So if you go to configuration, you can see here they are encrypted with some key. Okay, so that's the thing you can see here. Okay, so that's all. And now one more last option. If you want to use a customer key, just go SSE-C. If you want to use a customer kind of key, okay, for this we have to create a key first in your in the system. Okay, so if you see here, this file use this one, whatever I changed. Okay, so if you want to use customer key, you have to create a key in your local system. So guys, normally I'm comfortable a little bit with OpenSSL command. I don't know, Windows by chance have this command. Maybe some of the software I might install. So what I'm doing here, okay, I'm going for this particular practical where I want to upload my file. Okay, and before I upload the file, I want my file to be encrypted with the key that is there in my laptop, and then I will upload my file. Okay, that's what I want to do. So guys, this operation you have to do from your command line. Okay, by chance guys how to upload the file. So you guys know the S3 command. You can use S3 command to upload. Very quickly, let me show you the S3 command. You guys know already, but even though, so let's say I have one file. Let's say I go to desktop. In the desktop I have tons of files. Okay, let's say this is the file I have. I want to upload this file. So you guys know how to upload. So we can go AWS and say S3. I want to upload this file that is called copy. Okay, where I want to upload? In the S3, or in which bucket? The bucket name is test222. So this is a command, guys, very simple command. By chance I think I have already logged in my local system with AWS configure command, so they won't asking me any kind of error of permission or password. But now if you see in this bucket, this file uploaded. And by chance, guys, by chance, if you see this file property, okay, and if you see about the encryption part, this encrypted with KMS. Why? I haven't mentioned here because by default, encryption in my current bucket is this one only. Because I have set up this in my bucket side, folder side, that any file upload either from API or CLI or GUI, you have to encrypt with this particular encryption, whatever we have updated here. Okay, but maybe I don't want to use this encryption for my next file. I want for my next file. I want customer key to be used. Okay, so let me show you this demo how we can do. So I want my customer key to be used. For this, you have to create a key. So there are a lot of tools available in the market to create the key. I'm using OpenSSL. Okay, in OpenSSL, guys, there's a command called ENC you can use, and I want to create a key. Okay, so which algorithm you want to use? I want to use AES algorithm, or I want to use 128 size or 256 size of the key. And there's some kind of, guys, blocks in encryption. It's called CBC. So this is not so much important. Just what your key ID you can say. So this is my key one, some ID I'm using, and happen P to create. Okay. So there's some option, some of the method they might have depreciated. That's okay, but finally they create the key for me. So guys, don't worry about this command, right? Why CBC and all the things, but technically, finally they create a key in AES format. So this is one of the command. Otherwise, there will be lots of command available in the market. The most important thing over here and very critical for us in this command is this. This is your guys symmetric key I'm talking about. So by chance anybody get this key, even though you can see this key also, anybody get this key and they get my encrypted file, they can use this key to decrypt. Okay, so obviously I won't share this key to anyone. But where I use this key? So whenever I upload any file, okay, any file. So while uploading, I will use this key, okay, to first encrypt this file, then upload. Or because I'm using this key that is there that I generate, I'm the customer. This key is there in my laptop. So this is this called a customer managed key. Okay. So how can you use? So for this, let's go and check the help of AWS S3 CLI. Does they have any option where I can tell which symmetric key to use? Okay. So if you see the help of this command, of CP command, so SSL S3, and I am looking for 1 minute, AWS S3 CP command CLI. Okay, so I'm looking for CP command, and guys, if you see in the CP command, it is very clearly mentioned, right, that do you want to use SSE-C? That's what I'm looking for. So this option will enable customer side security. That's what I want. So let me write this option. Okay, so I want my file to be encrypted with customer key, and if you're using customer key, okay, then this is the option you can pass. Okay, so here you can tell your which customer key you want to use, and I keep my customer key very secure, and by chance in my case this is the key I'm talking about. Okay, so you use this key, but understand one thing, guys. Now your AWS won't have your key, so after you download the file again, the file will become encrypted. So to decrypt, you have to use the same key to decrypt, and again OpenSSL has a command to decrypt the file with some key. Okay, so that's what I'm doing here. So if I hit enter, the file uploaded. Okay, I'm uploading the same file. You can upload the same file again, no issues. Again, uploading the same file, and if you again go to your this bucket, let me refresh. this file uploaded, and now this time if you see, okay, this file is encrypted again. Okay, server side is disabled. I was in the wrong bucket. No, bucket is right. Okay, what happened? So let me again let me delete this file. So type perma and delete. 1 minute. It should work. Let me again check. So I'm uploading this file again. Okay, and let's see what come up. So object, this file again come up, and this time I want my key to be encrypted, but I don't know why they saying this is disable for this file. It shouldn't be. Logically, why they saying this disable? uh, I don't know why it should be enabled, but technically this is the command we have to use. Okay, we have to use. One possibility might be one possibility might be because the key that I use might not supported in S3. This is one of the property might be. Okay, so it is enabled, but I asked them to change. So the key I am using here, AES 128. So they also say it's depreciated. This might be possibility that key format is not supported there. So I can see the help of AWS. Okay, and ask what key we are providing. Does this kind of key is supported or not? Okay, I can see the further help and document and see. And by chance they're saying here in this customer provided key. Okay, this is the only valid option available. Okay, I think recently they have updated. So someday back I've tried, that was working. Okay, but they say only this option they supported. Okay, so but at least you get the idea, guys. So I don't want to further discuss. You just go and get convert a key in 256 format. You can get the command in the Google. Technically, this level of guys discussion we don't have in this training. So I just want to show you. I want to show you the different method that's available with the practical. Okay, so you can use this kind of command AES56 something like this, and you can generate a private key, and then you can use to to encrypt. Okay, so do this practical with you. Only thing you have to do, according to document, they say 256 supported. So multiple tool available. You can use OpenSSL, some commands, something like this. Okay, create a key, and command is exactly same. There is no challenge in the command. Okay, so it's a good thing to know. By chance they stop supporting this format or this AES 128. Only they support 256 nowadays. Okay, so this is guys about one quick demo of 3 different possibilities or 3 different method S3 support to encrypt your your objects. Okay, but in all the cases we are using same key to encrypt, and we are going to use same key to decrypt. Okay, so that's called symmetric key. Okay, now let's talk about asymmetric key, and that's very interesting. Okay, what's asymmetric key? So before guys, I will explain you what is asymmetric key over here. Before I explain you this topic, let me explain you one scenario. Scenario would be, let's say you have one web server. Okay, and web server has some pages, and one of the page in the web server website, you have a login page where they ask you to provide your username, and where they ask you to provide the password. And this is a global web server, means anybody in the world can connect. And let's say this web server had thousands of clients, and everyone connect to the web server. Okay, so one of the client we have in US, one of the client we have in India, one of the client we have Europe, one of the client we have in maybe let's say in Japan. Okay, so But you guys know this server may be anywhere in the world, and this client will be anywhere in the world because we are on internet. But you guys know one more thing: whenever any client connect to web server, they have to use certain route or path on the internet. Multiple countries there to packet flow, and multiple different router devices come up, and multiple different ISPs also come up. So there might be possibility the guy shooting in this ISP might might be there doing water packet going from this guy's laptop. Okay, they're going via this ISP, via the router, and some person, human being, sitting over there, and they have guys a way. So anybody who work on the router, so we can attach some extra cables, and there's a concept called mirroring of the packet kind of thing. Okay, and all the packages going to this router, these guys can mirror in their laptop, and there's a lot of tool like Wireshark, TC-Dump, where we can go inside the packets and they can read. So guys, if you guys from Earth Learner, if you remember guys, in my Hadoop classes, I show you TCP-Dump command, and we can use this kind of command to read the packet. It means these guys, if they want, they can read your packet and they can see what is going on. Okay, so it means if this customer from some city, some state in some country is hitting the web server, and web server are asking the login and password to log in, and these guys will provide the user and password, and this password go via the network, and these guys can see the packet. That is all known as sniff the packet. Okay, and after sniff the packet or see the packet, they can read the login and password. Obviously this guy will log in, but this guy also get the login and password, and they use this login and password to further attack your account. So that's called man in the middle attack. So they can do man in the middle attack kind of thing for you. Okay. So so what I'm talking about, it means if your packet is going via the network, is called in transit. Okay, sharing your data in a packet in network in transit is not safe. Don't share your plain text data in the network. That's the thing, guys. I believe you know. Okay, so what is a good practice? Good practice is, okay, let's say this is the customer A. So what are data the customer want to share to the server? First, this customer will encrypt this data. And guys, when you want to encrypt the data, you need a key. Okay, so let's say A want to share the login and password, this data, and they have a key. Okay, and this key they use to encrypt. And after the encrypt, new data come up. This is called ciphertext. Okay, and they can transfer data. So by chance anybody sniff your packet, they can read the data, but they can't understand what is there because it's encrypted. Or they can't be able to decrypt because they don't have the key, because A won't share the key. Okay, but the challenge here is when my data reach to server, again server receive the ciphertext, means encrypted data. Okay, and server want to use it. They want to check your login and password to validate your account or authentication part. But for this, server has to decrypt. How server can decrypt? Again, server also require a key. And without the key, how server can decrypt? And without having the key, they won't decrypt, and without decrypt, they won't use it. Because in this case, the only guy that has a key is this one. This one, A. Now, challenge here is why A require key? Because they want to encrypt before the transfer. Okay. Also, in this case, who will create the key? Maybe A will create a key here. A will create. A say, I am going to encrypt my data. So I need my key to encrypt. So my system or what a program I'm using, that will generate a key for me. Okay. But the point is, guys, here, because they use the key here, and this key look like a symmetric key. Okay. So other side, these guys also want the same key to decrypt. So technically, in this complete diagram, if you understand that, guys, here, what we achieve, we share our data safely. Nobody can sniff and break my data. That's a good thing. But bad thing is the other side, the web server has no way to unlock this, and without unlock, they won't be able to use it. So technically, this overall setup won't be helpful for us. Okay. So what is the challenge we have? Okay. Only challenge we have here is how to share this key to the server. That is the challenge we have. Okay. And this challenge is not in system number A. This B guy also has same challenge. C also have the same challenge. Okay, but because B is a different system, they will use a different program, and their program will generate a different key for the B. Let's say this key for B, there's a key for A, there's a key for C. Everybody gonna use different key because of security, obviously. Otherwise, there might possibility if everybody use same private key, or not private actually, same everybody use the same symmetric key. So this B may be sniffer here. Okay, B can use their key to unlock other data. So all the computer require a different key, and they will have a different key because randomly they generate, and that is the reason, guys, in our key we use salt. Salt is a way in the key world that will randomize your key every time whenever you create. Okay, but technically here the challenge over here is, the good thing is everyone has their own private key. Every private key is there in their laptop, is safe and secure. They can use this private key to encrypt. Okay, every data going in my network in transit is encrypted, but only thing is all these guys A, B, C, D, E here, how they transfer their respective key to the server. Without server have the same key of A and B and C and D, they won't able to decrypt their data. Okay, that is a challenge come up. So challenge is we have to transfer a customer key from the laptop to the server, so the server will use their data. So this is the challenge we have. So one way we can transfer is simple. This is the key we have. Key is the data. We can share our data to the network. But if you guys you share your data in the network, this guy can also read your key because it's the data. If this guy you read your key, then there's no meaning of encryption. They can also decrypt your ciphertext and get your data. So I can transfer my key, over the network. Other possible would be if I know my server guys, I can do WhatsApp. I can do mail. But technically, guys, it's not like 2 or 3 computers we have, right? It's a millions and millions computer. If you talk about Facebook, Google, no. So technically, none of the client can able to transfer the key via this kind of medium, right? So this is not practically possible. Okay, so only possibility to transfer this key, we have to use certain mechanism or certain method that is called asymmetric key. So asymmetric key is a concept that is used, okay, for 2 purpose, and one of the purpose for asymmetric key is to transfer your key to other end. Transfer which key? Your symmetric key. Okay, a lot of guys think asymmetric key we use to encrypt the data between server and client. So that is not that true. Okay, this is not true, right? That actual fact about the asymmetric key is, okay, our customer key that we are using to encrypt and decrypt data. Okay, so this from the customer, we are trying to send this key to the server, and who will gonna help me? Asymmetric key. So let me show you guys how the thing work. Okay, so so what asymmetric key has in this key, actually they generate 2 different keys. This is called asymmetric. First they generate a private key. This is again one kind of key. Okay, and from this private key they generate a public key. So again, a lot of guys think they generate both the key together. It's not like this. If you start doing practical, you come to know first we generate private key, and every private key has associated very unique public key in the world. Okay, so it means if you want to generate this private public key, you need private key. Nobody can generate this public key without having their private key. So there's 2 different key we require here. Okay, this is one thing. So nobody can generate public key. Remember this thing in your mind, without a private key. Okay, this is one thing. Okay, so it means private key is very critical. Second thing, you just keep in mind, if you have any data and if you want to encrypt this data, okay, encrypt this data, we need public key. Public key is the one who encrypt the data. Okay, and after data encrypted, it's become a ciphertext. Okay, so only one who can decrypt this data, okay, is your private key. Okay, so what I mean by this, if you use public key to encrypt, same public key you can't use to decrypt, right? Even though if you encrypt your data with a public key, so you say I am the one who encrypted, but you locked down yourself. Okay, you won't able to decrypt this data back. Okay, the only one who can decrypt this data is the private key. So technically, if you think, guys, in both the contexts, private key is very critical, and that easy reason is called private. Private means is like secure key, and we always advise never share your private key to anyone in the world. Or what, this is a public key, so we always say share this public key to everyone in the world. Okay, so just keep this two thing in the mind. Why it's happening? There's a lot of mathematics behind the scene, right, for this, but but this is the concept, the way an algo work, and there's a lot of algo guys in the market who uh, who can able to create a private key and public key for you. One of the very famous and typical one, older one, I can say DSA. Then we have RSA, then ECRSA, and a lot of algos or algos we have in the market for asymmetric key. Okay, but keep one thing in mind. After you encrypt a public key, only private guys can decrypt. This is the one main key. Just keep in mind. Okay. Now this asymmetric key approach we use to solve this issue. Okay. So what we gonna do here? So now understand here. Okay. Very interesting. I very much like this concept. So let's say this is your server, and they have lots of customer client across the world, and they want to do a secure communication. Okay, because if they transfer, I already explained this concept. But servers say, I want all of my client want to share some data to me, and I want their data to be very much secure, right? Nobody can have able to see and hack it. Okay, so what I did in my server side, I created two key. One, I created server private key, and when I created server public key. Okay, I know private key is very critical, so I will never share my private key to anyone in the world. I keep this key in my hard disk. Okay, or I can keep this key in some of my key management system, and in AWS world, this may be KMS. So I keep this key in some of my system. I never provide this key to anyone. Okay, and second thing, this is a public key. I will provide to everyone in the world. So this is key I have. Let's say I have one website, and I keep this key there and ask everyone to download this key. Or maybe I will, when any new client come up, I will share this key to anyone. So somehow I will provide this key, because key is like a big data, and or this key they normally keep in one file. Okay, so so this one minute. So we provide this key to everyone in the world. So finally, this customer also have access server public key. This customer also have service public key. This customer also have server public key. So everybody somehow from this website, public website, or some other medium, they will get the access, and everybody has the same public key, right? Now let's now from here, guys, same diagram we're gonna start. Now here is okay, my first client want to share the data and the password. Okay, data. So what this client will do for sharing the data, client will create their own symmetric key. So you're going to use a word called client one symmetric key. Okay, and from this symmetric key, they encrypt this data. Encrypt this data. Okay, but the challenge is I already explained to you. Okay, they can transfer the data, but server don't have a client key. So intention here is, okay, before they do any operation here like this, how client will share this key to the server. Okay, so it is something like this. Let me again explain in this example. Let's say this is client 2. Client 2 create their own symmetric key. Who will create? One of the program in the client they will create. And normally, if this is a web server, let's say this web server is Facebook. So normally, if you talk about client is like a Chrome browser. So normally, browser is a program, and they are the one who create actually key for us behind the scene. So Chrome browser is one who create a symmetric key for us. And first thing, what our requirement is, we have to transfer this key to our server. Okay. So what normally we do, this key is like a data, and because we have server public key, we encrypt this data. So finally, what we have? We have one box, client to symmetric key, that is logged by server public key. And now, guys, client to, if they want to again decrypt, they can't decrypt, because only way to decrypt this box is a server private key, and only one in the world who have this key is the server only. So anybody stolen this box, anybody sniff this data in the network, they won't able to do it. So very easily we can share our data to the server, and because server has the private key, they use this private key to unlock the box. And finally, what server has got? Server has got client to private key. Client to private. So finally, what have this? So this, we use public private key concepts. This is called asymmetric concept to transfer our symmetric keys. Now both the AND has the symmetric keys, and nobody has in the between in the network or ISP. Other guys have the same symmetric key. So now further onward, any data from client to server, server to client, because client has to share the data, server also has to share the data. For example, you are the one who log into Gmail, so you will lock your login password with your private key because you have the private key, and server will unlock because they have your private key. So not private key means actually the symmetric key. And server want to transfer your data, maybe your emails or emails data. So they again use your private key, so your symmetric key only to lock, and because you have a same symmetric key, you can unlock. So further, all the communication of data between client and server, right, would be again purely encrypted. But for this encryption, they are using their client symmetric. Okay, so this is the guys whole process. But if you see here, encryption again we are using for transferring the data or packet. This is called in transit. Again, we are using symmetric key only. But how to transfer the symmetric key to the server, we take the help from asymmetric key. Okay, and sometimes it is also known as negotiation. So asymmetric key means public key, private key help me to negotiate or transfer the client symmetric key to the server. Okay, so that's what they are. And guys, this is sometimes also known as session. Sometimes I say from a Gmail or to Facebook, our session has been created, and this session is very secure session. Okay, why? Because we transfer our key. And guys, this process from start till last, start means when we use public key, private key pair, then this guy transfer the key. Okay, so the initial process before we start transferring our data actually, or like login a password or other data, okay, this process is known as SSL TLS handshaking. SSL TLS handshaking. There's some more thing happen in SLTS handshaking, right? There's some use of CA also come in play. Maybe we might discuss in the future. But technically, this process of using public key, private key pair, and client symmetric key to send to the server, this steps and process is known as SSL TLS handshaking. So SSL is secure socket layer, TLS is transport layer security. Both are different process, but we always use both the name together because SSL is a little bit older kind of process. TLS is a little bit newer kind of process. To all the shortcoming we have in SSL, we improve in TLS, something like this. So whenever you heard about SSL, normally we mean to say TLS, but normally we use this name together. SSL TLS handshaking. Okay, so that's what we use. So finally, if you talk about the use of asymmetric key, So one of the use of asymmetric key is doing uh, having having a private key and having a public key, and this guy gonna help us to negotiate. Doing a handshaking means transferring the client symmetric key to the server. And finally, those key we're going to use for encryption. So that is the reason, in simple term, we always say we use this key pairs for one thing that is called encryption. So in the simple term, we use this term that we use these guys for encryption, decryption, but technically they are not. They are meant for secure transfer your symmetric key of the client. But normally we use asymmetric key for encryption, decryption, but we never use. Okay, this is the one thing asymmetric use for. There's one more use of asymmetric key, and this is for checking signature. Okay, or not checking signature. I can use the word called validating your data. This is called validation. Okay, so what I mean by this, I will explain you in a minute. Okay, so asymmetric key used for two purposes. One purpose I explain you. This purpose I will explain you after some time. There's two purposes where we can use asymmetric key for. Okay, so let me show you the demo. But I think, guys, it's pretty clear what is happening behind the scene, and I think it's now very clear actual purpose of public key and the private key. Okay, and guys, normally I want to tell you one more word here. Okay, if you from your client, if you share your data to server, and normally, guys, server we communicate with the protocol called HTTP. So whenever you heard this term HTTP, it always means clear text. But if you're using SSL TLS handshaking, or all the data is transferring in secure way, so this is known as HTTPS. S means secure. So it means behind the scene they're using SSL TLS handshaking. It means behind the scene, server has a private key, public key, client is generating their symmetric key per session. Okay, and there's one more thing, client will create their symmetric key per session, right? So for example, from my browser, for Google, I'm creating different key. For Facebook, I'm creating different key. If I again log into Facebook, they will again I create different key. So I keep on creating my symmetric key every time when I connect. I initially again I reconnect to those applications. It's something like this. So the guys, there's very detailed discussion I have done. As such, we don't require, because a lot of guys asking me to discuss a little bit in depth about cryptography with basic level also. So I try to touch this concept. Okay, but let's go. But guys, finally, if you see in this whole diagram, the most important key for us is private key, because client key they always create new. Every time they log into Facebook or they again create a session to Gmail, they create a new key. And public key is not at all secure, because we want to share this key to everyone in the world. Okay, so there's no challenge. Okay, even though same kind of communication happen with Facebook. So example, right now in my let's say I'm a client, I'm a web client, or I connected to let's say Facebook. Okay, so these guys also have their private key, and they have also a public key. Or whenever you guys connect to Facebook, somehow they will transfer their public key to you. You can see this. Okay, so for example, in this browser, I'm opening my Facebook. Behind the scene, you guys know there's a pure secure communication. How I know? There's a lock in the top. This locks represent this is the secure communication. Or maybe I can open my notepad, copy this URL. You can see it's pure HTTPS. Okay, it means when I connect to Facebook, somehow they provide me public key. Obviously, they never provide their private key to anybody in the world. Okay, but how can you check this? So if you click on this lock symbol, okay, the option called certificate. What certificate I haven't discussed yet. But if you click here, Okay, and you can see here this uh, this information come from Facebook, and if you see the detail, okay, here they say this is the public. Okay, so Facebook has shared a public key to our browser, and our browser is a program who gonna use this key for what? So my browser behind the scene create some symmetric key, and the symmetric key they log with this key and they transfer to Facebook. Now Facebook also have this same time my symmetric, and now all the further communication you see here between any data is transferring, or we see all of data here is going very much encrypted. Okay, there's a one thing. What is certificate? I haven't discussed yet. We might discuss what is certificate. And one more small thing, they might be using DSA protocol, not only DSA, ECDSA. DSA very older, so they're using EC DSA protocol for a symmetric key. Okay, so this is one small thing. So, but in all this communication, guys, understand one thing. The most important key is a private key. Now, point is, guys, who can create a private key? Normally, server side is the one who create the private key. Okay, but where we keep our private key? Okay, so there's a point. Okay, and this because we have 100 different server in the company. Every server has their own private key. So again, here we can use the help of KMS. So key management system will keep my private key in their storage. Okay, so let's go to KMS again. So you go to KMS. But understand one thing. Right now we can compare, guys, asymmetric key with symmetric key. So if I ask you, do you require you have a file and you have to store your file in your hard disk, and before you store you have to lock it. So guys, if you understand, in this case there is no concept for private key and public key, right? Why we require this? This is my local storage, this is my local file. Why I need to have public key, private key. I can directly use my symmetric key to encrypt and store here. Okay, so that was, guys, I was trying to explain that point in time. It asymmetric key doesn't mean we have better than symmetry, right? Both the keys had different use cases, and the main use case of asymmetric key I already explained to you. Okay, so I have two keys here. Both are the keys symmetric key. Okay, let me create one more key here, and this time I'm going to create a key for asymmetric. Okay, even though they say they will create a public key and private key pair, they use for encryption decryption. But I told you the actual use is not encryption decryption. Actual use to transfer your client key. But they normally this is the way we always see. And other use case also we have sign and verification. This is called validation also. So this again one more use case of asymmetric key, very much useful. I will explain you. Okay, so but in my case I am going to use asymmetric key here for encryption and decryption. I click here. Okay, and now here in the specification they're asking you which protocol you want to use. Here they support only this 3. So I'm going to for RSA 2048. Actually this 2048 is the size of your key. They will create a private key of length 2048 bytes. So big key actually altogether. But bigger the size you have, better you have security. The bigger size you have, more it take time for CPU processing. Okay, so I'm going for 2048 only. Click next. Again, your key name, or I can say alias. Let's say my asymmetric asymmetric key, something like this. Okay, and next, again same thing. Who can admin your IAM role? So I'm not focusing here. I explained you this concept already. It's exactly the same concept. So root account can able to access this key. Okay, that's all. So now guys, key is created. Now you can see one difference here. This is no symmetric key. This is the RSA, and RSA is obviously asymmetric. but we create this key only for one purpose. The purpose of this key is encryption and decryption. Okay, so we can use this key to encryption decryption. Even though, guys, typically this key is normally used for transferring your client keys, but we can use this key for the way we use asymmetric key also. So same way you can also use if you want to test also. So we have a file, we can log with public key, then we can unlock with a private key. So same way also we can use. So if you want to see a very a quick demo of this, let me show you how we can do. Okay, so so this is the key I have. Okay, and here you can see this is the key, and guys, there is no option here you find where you can find a private key, because private key AWS will store in their storage. They never provide to you, but you have a public key that you can get here. Okay, because public key is for public, and obviously this public key you transfer to your client. Okay, and your client gonna put their symmetric key, or maybe client can simply lock their file also, whatever they want to use, but typically they meant for handshaking. Okay, so I can download this key also for you. Okay, now what I'm doing here, I'm showing this practical a little bit in a different way, means something like this. So what I'm going to do here, let's say I have a file .txt that has some data. Okay, so what I'm going to do, I'm going to log this file with public key. Okay, and because I log the file with public key, so only guy in the world who can unlock this file, this called ciphertext, is your private key. And the private key I have in my AWS cloud in that key KMS services. So they are the one who can unlock. And in the KMS, the only account is my root account. They will get the access, because in this key I will apply in the key policy that the only admin to manage is there's no admin here, so is my root account. The root account is the one who can admin this. You can click here, you can see only root can access. Okay, so technically in the entire world, only my account, root account, can able to access the private key. They can't see, but they can access. Okay, because this guy keep this key in their storage. Okay, so if you want to see this practical very quickly, okay, again I'm repeating, you can use a symmetric key for doing like normal operation, encryption, decryption you can use, but it's not meant for this one. They're meant for SSL, TLS, handshaking, that what I explained to you. Okay, but if you have normal data, you can also use this data to lock or unlock. There's this extra thing if you want to do, you can do here. So let me show you how we can do. There's a lot of tools available for this. So what I'm doing here, I'll go to let me create one file, let's say secure.txt file. Okay, my credit card number. Okay, save, and I want to guys log this file. Okay, and the way I'm going to log is no symmetric. Normally if you want to log the file, the right way is symmetric key only, but just for showing you a demo, okay, that public key, private key pair, how it works. So I'm locking this file or encrypting this file with with this public key, private key pair. Okay, so we can use OpenSSL command to do it. And OpenSSL command, they have a option called RSA utils. Okay, so I'm using RSA utils is one options they have. I think they have. Let me check the help. -help. Yeah, they have. So this is a command we can use. Okay, and guys, here is the thing is very clear in this command. They say if you want to log any file, give me file name. Okay, after encrypt, I will give you file to encrypt. Okay, and for this, obviously, you have to give me public key. Okay, so just provide me a public key. Okay, and value key, just give me the value. Okay, so these are the option obviously we have to provide here. And obviously one option is encrypt, because here my plan is to encrypt. Okay, so we are going to encrypt, so this option we have to provide. Okay, so these options we have to do. So what I'm doing here, I'll go out a different terminal. And because my plan is to here we have to provide a public key, and by in my case I download public key in my download folder. So let me go there only, or let me create, guys, very quickly the file there only, so I don't have an issue of path. So credit card to do something. So I want to log this file. So again, I can say open SSL. There's RSA utils. I want to use some RSA protocol behind the scene. I want to encrypt a file. This option I'm going to use. Okay, I'm encrypt the file. Okay, and which file? In file called sec.txt. Out. Okay, so out would be which file you want to save the output. Let's say this is secure underscore encrypt.txt. So this file they create and they keep my encrypted data in this file. Okay, and for encrypting, I have to provide a public key. You have to give a RSA public key. So hyphen pub in. Okay, and where is the key? You tell me the path. So I have the key where I already downloaded in this file pub key something. So let me give the path pub key something. Guys, this is a big name, but this is a file I downloaded, the name of my file. Okay, and logically anything else might not be. Yeah, so there's no error come up, and finally this file has been encrypted. So let's say anybody who want to encrypt the file, they need public key, and everybody in the world has public key. But even though I have encrypted, but if I want to decrypt this file, I can't. And obviously, guys, after you encrypt the file, your main file you don't keep with you, you will delete this file and terminate this file. And if you try to open this file that is encrypted, nobody can able to see the data. It's purely they can read, but they want to able to understand what is there. They can delete also, but it's not clear what is there. Okay, so only way to unlock this file is called decrypt by having a private key, and only private key available here in my case is my KMS service. So KMS service is the one who have this key. Okay, so what can I do? I can go KMS service, get the key, and there's no option directly here. We can use help of command line. Okay, so in the AWS, we have a KMS command, same kind of command we used in my last class also. And if you very quickly check the AWS KMS CLI options, okay, and you will find one option called encrypt. You can encrypt. So that's what I'm looking for. So encrypt is a way through which we can unlock our data. So this option I am going to use, even though guys see they support this RSA. Okay, because my key is been, if you see my KMS portal also, this key I have converted from this algo. Okay, so they support this. That's a good thing. So encrypted is a command I have to use. Encrypt is a command I have to use. Okay, obviously not encrypt, obviously decrypt, right? Let me go out, because right now my plan is to decrypt, right? So click on decrypt. Okay, and in the decrypt, these are the options they have. Okay, because my plan is to decrypt, right? Not encrypt. Okay, so in the decrypt, what can we do? So obviously, guys, we have to provide a key ID. Key ID. Which key ID? Where my key is. So my key is here. Okay, so this is my key ID. So I have to provide my key ID. So I'm telling my AWS in KMS, just go and find this key ID, and this key ID have my private key, and this private key is there somewhere in your storage. Go and get it and try to unlock my file. Okay, and so obviously you have to give your file name. So for this, okay, you have to provide your blob. Blob is object, object means file. Okay, and here your file is this one. So I guess told you guys in my last class you have to use a file B protocol to provide your file, and file name is this one. Okay, so we can use decrypt. We provide a key. The guys, this is not your key. This is ID. This is name number. Key is there in the AWS storage. From there we get it. Okay, and that's all. That's the only thing we do. And if I hit enter, okay, error come up. Okay, and by looking at this error, what can we conclude? The conclusion might be in this error is they say there's some invalid cipher text exception. Okay, according to my knowledge right now, what they're talking about if you want to decrypt this file. Okay, 1 minute, or decrypt this file. Okay, they say I support RSA. Okay, in RSA also, guys, we have a multiple different algos, but I only support this algo or this algo. Okay, so this is actual algorithm we support. So you provide this algorithm here while decrypting. Okay, so I'm going to provide, let's say, this particular algo name. Obviously you don't have to memorize this document for this. Just go and check what they support. Again, the good thing is again same error come up. Just trying to prove you this issue is coming because of the algorithm. So they're saying you we are this is algorithm we support to unlock. So it means while locking also you have to use the same algo to lock. Okay, so anybody who will use this public key to lock, we have to ask them that you have to use OAEP algo, and that's what, guys, this option is available in RSA command also. So they say we support, I think they have the option, yes, OAEP algo we have. Okay, so technically what I'm talking about, so while encrypting we have to pass one more option. So this command was not complete. I just want to show you that error also by chance. So you have to pass this particular option also here. You can put anywhere. Which option? So why this? Because the private key wherever we're keeping, they say I only support this option. Okay. Now my file encrypted. Now I can go to my AWS to decrypt this, and I'm passing this option here. I think this should support. Yeah, they support it, right? And finally, this work. So technically, you can use public key, private key to lock, unlock also. It will work because the use is finally is encrypting. Either you encrypt your file, you encrypt your customer keys, but main use case for public key and private key is for locking the customer key while doing session. Okay, but finally they unlock. And after the unlock, they give you plain text in this format. And I told you guys, whenever you want to show a plain text, don't show directly, right? Otherwise, anybody can very easily see your data very quickly. Always show the plain text in encoded format, and this is called base64. Okay, but there's a lot of tool available in the market to decode. So I told you already, base64 decoders tools we have in the market. We click here, put your data, okay, and decode. What you get? You get your actual data. See here. This is what, guys, I had put in my file. So you see actual data come up. Actual data come up, right? So everything is working great. So only challenge is, okay, if you provide this file to anybody in the world, they use all the supercomputing power that is available in the world, all the supercomputing power. Nobody can break this file data in millions of years also, right? Or thousands of years, I can say also. So this is so much secure. Okay. So they put all the computing power, they put hit and try A, B, C, D, all the try they do, they weren't able to break because this password is private key is in 280 2048 size, that much bigger in size, right? So is if you try to create a combination of guessing the private key, it is huge, right? So so finally, it's so secure, but the purpose for RSA DSA is to have a transaction between server and client. Okay, so this is one quick demo for this. Okay, now there is one more use case of public key, private key. Okay, uh, over here. So if I create one more time, okay, is for signature check. Okay, so it is like a validation. Okay, if you have a data and you want to pass some data to somebody else, and somebody in between change your data, right? Some bit, maybe you're transferring some amount, and now it is everything is digital, and you transfer $10,000, and somebody remove 10, it become $1,000. So how next guy come to know come to know that some part is missing, some data we lose, or somebody has tuned or tweak something in the data. Okay, so we need some kind of verification that's called digital signature. So public key, private key also we can use for digital signature. So again, guys, I think I'm going to very detailed discussion on cryptography. So I'm not showing you this demo right now, but anybody who know, right, that there's a lot of uses of digital signatures. So everywhere you want digital signature, technically it is because of public key and private key. Okay, so maybe if you want, maybe in my upcoming some of my classes, I will explain you how we use. But there's one more use case of public key and private key that is for digital signature. Okay, otherwise everything is same. So whatever file you send, create a signature. Okay, and they will verify from the signature, and and they will confirm that whatever data we have mailed you, we send you, is true or not. So let me show you very quick information about this. So if you guys ever check your Gmail, okay, let's say if I mail you, even though I have one announcement for you. Announcement is last to last class I asked you to write a blog. So a lot of guys has written the blog, is very appreciated. But our team has selected 3 guys. Okay, and these are the winner of that blog. So I just want to congratulate Vinuda, all right, Sachin and Banka, all right. So congrats from my side. I've agreed, right? Even though Banka, you're just in first year, Vinuda, your second year and your third year, so you have did a great job, and you have written a great use case blog or article, something on SQS. Okay, I think my team will have some kind of special goodies or something for you. All right, my team will connect to you and they will do the further processing. So from my side, again, want to congratulate. Okay, this is one thing. So guys, right now this mail come to me over here. You see this, the mail come to me. Okay, there might be possibility from wherever the mail come to me, the first mail will go to mail server. Okay, and the guy who is maintaining the main server, they might they might change some name, they might remove L here, they might add some new line, they might change some password or some credentials or some data from here. Okay, so how I come to know whatever data reach to me are is the exact same data whatever the somebody sent to me. So this concept is called integrity. So how we can check the integrity of your data, images or whatever you have. Okay, so normally when you transfer any data in the mail systems or anywhere, almost everyone is providing you a signature. Okay, and by the help of signature, we can validate or verify the data come to us is in the same format. There is no change. There is no integrity change over here. So if you see in the Gmail also, okay, and if you see so original here, I don't know how you see this part or not. If you see the original of this message, okay, and if you go down, okay, here guys they're talking about signature. Signature, okay, and here guys if you see again for signature they're using RSA algorithm. If they're using some kind of hashing also, what hashing is again different topic. I don't want to go there, but with this public key private key they're using hashing also, and some kind of signature they send to you. Okay, and there's a tool available, even though there's tool available from Google also, and we can add extra add-ons also. So here in the last they might give you some warning error that something has been missing. Okay, so technically what I'm trying to finally tell you here is whenever any data, message, image, video come to you, or you download something from the internet, uh, signature is a way that will help us to verify or validate that there's nothing is missing in your data. It is come in the same exact format the way it has been sent. Okay, and very critical guys, you think of banking process, right? Thing if you just remove 2 zeros, technically the computer perspective, 0 means just 1 byte or 4 bytes. Just remove 4 byte, your 1 million or 10 100 million might go to 1 million. So it's so critical. It's not a small thing. Okay, so technically your public key private key pair also help you in this way. How? There's a long process. I don't want to discuss there, but this is also the one who will check, who will do for you. Okay, you can go and create. So let's try to use this one. Okay, this is some name, digital key, something, and let me next. Again, same thing. So process of creating is almost same, but the use case wise, they're different. Now this key is only for verification purpose. Okay, so it is work something like this. I will tell to entire world, if anybody want to transfer some data, use my public key. And at this time again we are using public key, but this time public key is not for encryption. Use this public key for creating the signature. Okay, and then transfer data to me. And I have my own private key. Before I use my data, okay, I use my private key. Again, I check the integrity of my data from private key. I match with your public key or what we send. Then I confirm if something is changed or not. Okay, so there they use some kind of hashing also. So I don't want to discuss in that much level. Okay, but technically almost everything guys about KMS I explained to you. I told you guys in my last class also, we don't have this topic in so much detail. If you go to AWS Security Specialist Program, almost everything that is there about KMS, almost everything I have covered here about KMS, right? Just for external knowledge, I covered here. Okay, so that's all about this particular topic. We had one more very interesting topic, very much interesting topic. Is a new service that's called ACM. Okay, but guys, I can cover this topic in 5 minutes also right now because it is like a CA. Same diagram somewhere we can use CA also, but I want to show you the pure practical of this diagram with elastic load balancer, because this is a very common thing we have to use, and a lot of guys also asking me. And then also I will explain you what is SSL overloading and edge end-to-end encryption or edge encryption, right? So a lot of thing is there, very interesting topic, very much useful. I will explain you in my next class. One more quick announcement I have, guys. Next week guys, we have a very great workshop on AI. Okay, and very much exclusive workshop it is. It's a pure artificial intelligence. And interesting thing is, it's not only AI, it is over AWS. Okay, so interesting thing here is, uh, and this is the way that the thing is be changes. Now everything we are migrating to or migrate to AI world, but the biggest role who work as a backend for managing the AI is the cloud. Even though for this, especially AWS has their own special program called machine learning program. But from there, I pick almost all the interesting topic and to set up the entire AI over the AWS. So it is very much a recommended workshop, especially for the AWS class, because you guys are doing a lot of things in AWS world. So by having that knowledge, also it will give you a lot of extra benefits. So this is the content of this workshop. Okay, and because here there are lots of services related to AI we have added here. So Code Guru, Comprehend, Lax, Forecast, Dexter, Candra, Fraud, Recognition, Personalized Translator, Poly, Transcribe, right? So almost all advanced AI services we have put here. With pure practical workshop of 2 days, Saturday and Sunday next week. Okay, so highly suggest, especially the AWS guys. You can see that then the power of AWS and the cloud, and you can see how powerfully we can build your AI setup. So technically, this workshop is not technically only talk about AI. We're going to build the entire AI. Okay, you can think we're building the entire human being. So this is the eye for the human being. This is the mouth of the human being. The way human being use their mind and intelligence. Same kind of setup we are going to connect and build here. Okay, chatbot and all the things over here. Okay, by chance of this is very much uh, advanced kind of workshop, but for the earth learner guys, we make this workshop free. Okay, otherwise all other Linux World students, we make this workshop very much in nominal price. Okay, and I think over here you guys are the part of Linux World student also. Okay, but the only point why I'm announcing today, because a way it has been designed, today is the last day for this one. Otherwise from tomorrow the price might increase. It will increase. All right, so John to update from my side, right, that this is very much useful workshop for you guys. Okay, because you guys are doing AWS and we are doing lots of things here. Okay, so that's all for my side in today's class. Okay, ACM I would like to take in next class, means tomorrow, in very much in detail, and I can do mostly one class in setting up the entire environment. And lots of topic guys will be repeat and revised tomorrow again, like load balancers and other things. And most interesting thing here to set up ACM. So that's all guys from my side. Uh, if any questions you have, you can ask me. Yes, Weber, we might discuss somewhere in my class. I will discuss about SSRF attack, server side request forgery. So that is not at all, uh, linked with encryption decryption, right? It is a different attack and can be handled by in different format. Okay, but we will definitely try to discuss this topic also.